Hey guys, this is a combining like terms workshop. I just wanted to go over why we combine like terms and how it is useful when we're solving equations or evaluating expressions. Combining like terms is simplifying expressions and equations to make them easier to solve. Like simplifying fractions make them easier for us to understand. When we're giving something like this is a really long expression, and expressions can be endless. It can include multiple operations, it can include multiple numbers, multiple variables. But when we see terms that we can put together, we're going to make this very long expression a little bit simpler to understand. And we're not always going to be able to combine like terms, but if you see that you can, it's going to make it simpler. Okay, so something like this, 5x plus 4y plus 5 minus 2x. In 6th grade, we learned that a term is a chunk. Okay, and our terms are separated by a plus, minus, or an equal to sign. So for this expression, we have 4 terms. We have 4 chunks. I'm going to separate them out so it'll be easier for us to see what all we can combine. To combine terms, the term has to have the exact same variable raised to the exact same exponent. Okay, so keep that in mind. And then any regular numbers, regular integers can be added together as well. So we have an x, 5x. So we're going to have a team of x's. We have a team of y's. We can't put those two together because it's separate and different variables. Then we have just an integer 5, and then we have a negative 2x. Now this negative 2x I can combine with this 5x because it belongs to the same family of variables raised to the same exponent. In this case, it's just an x. So when I combine like terms to make things easier to understand, this now becomes 5 minus 2x, 3x, plus 4y. There's nothing I can combine with the 4y, so I'm just going to have to leave it alone, keep it the same, plus 5. We weren't able to simplify this expression very much, but we were able to go from 4 terms to 3. And overall, that's going to be less work later. Here's another example. I see 4 terms. I'm going to break them up. And then I'm going to create these families of like terms and combining like terms. So we have a family of x. I'm also going to include this family, this 3x to the family. And then we have 2 integers that we can also combine. So when I simplify this expression by combining like terms, it becomes 5x plus 3x is now 8x. A positive 35 plus 2, now I have 37. Plus 37. 8x plus 37 is much easier to work with than 5x plus 35 plus 3x plus 2. Okay, so I'm going to separate my terms, see what families I can make. Here's an integer, here's another regular integer, and then I have my family of t's. So 32 plus 8 is 40, plus 16t and 12t is 28t. We're able to simplify from 4 terms to now 2 terms. Okay, let me move on to one with maybe some more exponents. Well, this one's actually pretty lengthy, so let's go and do this, just the c. When there is a minus or a subtraction, I'm going to bring that sign with me. A lot of you guys don't see those two things as being the same, but they are the same. It's however you want to think of it. A minus 3 has the same value as a negative 3. So I'm going to have my family of a's. A. Here are my b's. Here's another a. Let's combine these like terms. 19 minus 17 is 2. 2 minus 2 is 0. So I have no a's left. Actually, let's put this one up top. A positive 9 minus 6 is 3b. Minus 3b is also 0. Here's a good example why combining like terms is going to save you a lot of time. If you do take the time to evaluate this very, very long expression with 1, 2, 3, 4, 5, 6 terms, you're going to do a lot of work to then realize our answer is going to be 0 because all of the terms end up canceling each other out. Okay, I wanted to give one. This is one to note. when you're subtracting a negative number, it turns into a positive, so just be careful there. Okay, here's one with exponents. To combine like terms, the like terms have to have the same exponent. Whoops, let me drag all these down first before I lose track of what I have. They're going to have the same exponent, and it's going to be raised to the same power. So I cannot combine a regular x with an x squared. Okay, those are two separate families. Then you can combine these. Let's see, an x plus 3x is 4x. If you don't see a coefficient, then it's implied that it's 1 because I can see only one x there. So that's 1 plus 3 is 4 minus 5 is negative 1x, which is also just negative x. Negative 3x squared plus an x squared plus 1x squared is what this is a negative 2x. Negative 2x squared. So when I combine my like terms for 3x plus x squared minus 5x plus x minus 3x squared, it's pretty complicated. When I combine like terms and I simplify it, it turns into negative x minus 2x squared. Okay? I think that's, oh, one more thing, something like this. Pull out these terms. It has to be the same variable raised to the same exponent. It also has to be the same combination of variables. So if I have a combo like this AB, this is going to be different than just A and just B. So you can combine your double variables, but it has to be the same combination of variables with the same exponent. Okay, so this simplified would be A minus 2AB plus B. Okay, hope that helps.